At this question here. Rectangular shaped parking lot has an area of this expression. Determine the algebraic expression for the length and width of the parking lot. If m is a value and n is a value, find area. And if m and n are different values, find perimeter. So what's unique about this question is that we have two sets of variables in the expression. So we'll write it out here at the bottom. 9m squared minus 27mn plus 20n squared. Okay. What we'll do is, again, it's a rectangular shape, which means we're going to be doing some factoring to figure out the length and the width of this rectangular shape. But the tricky part here is the fact that there's two sets of variables. We have m's and we have n's. Luckily, that style of factoring called fearless factoring works really nicely with this stuff. We'll find the factors of the first term and the factors of the last term. We'll call them A and C. And the products of the two of them got to add up to what we call our B term here. So factors of 9m squared are 3m times 3m. And you'll notice I'm purposely writing in the variables because there are two of them. In the other examples, we just assume the variables, so we work with the actual numbers. But here, 1m and 9m, okay? It'll come in really handy because of the two variables. 20 has quite a few of them, so actually what I'm going to do is I'm going to move our example of a rectangle here. And factors of 20 are 1n, 20n, 2n and 10n, 4n and 5n. And we know the products of the columns need to add up, need to sum to our b value, which is negative 27m and n. Now, because we've set up the columns to have m's over here and n's over here, whatever the products are going to be are definitely going to have an m and an n attached to both, right? Because an m times an n, they're not similar terms, so we can't actually put them together. So I'm just going to put them in the start. That way we can focus on the coefficients in the numbers, okay? Off the top of my head, I don't know the answer to this one, so we're going to try a couple. I think we're going to try with the 3's and see if we can get a value here. So we're going to start with this first set. 3 is 60. No, the first set's not going to work. So I'm doing these really quick in my head. So 3 times 20 is 60. 3 times 1 is 3. 60 and 3 is never going to work. And 3 and 60 again is definitely not going to work, right? Because these are both the same value, we can kind of do some quick mental math to get an idea. 3 times 10 is 30 and 6. 30 and 6, that's not going to work. 3 and 4 is 12. 3 times is 15. 12 and 15 work. Okay, so let's take a look if this is the connection. 12 and 15. They both need to be negative, which works out fine because negative 4 times negative 5 is positive 20. So it looks like we've actually found it. So what we're going to do is we're going to set up our two sets of brackets. We know the 3m's will be the first terms in both. And because the first terms are the same, it doesn't actually matter which bracket we put the other terms in. So I'll just put 4n here and negative 5n there. So we have our expressions for length and width. And again, assuming that m, well, actually, it doesn't matter which m or n being positive or negative. It's going to change our numbers here. These ones are a bit unique. So we're just going to guess. This won't be to scale. We're not 100% sure which is going to be the longer or the shorter side. So this is 3m minus 4n, and this will be 3m minus 5n. Now the previous page, no, that's not the right page, above. It says, what if m is 1 and n is 3? What's the area? So area is equal to what if m is 1 and n is 3? Okay, this is some simple substitution. We'll do area in red, see if we can figure it out. 3 times 1 minus 4 times 3. Oh, this is interesting. So what we're going to get here is, let me make sure I've written those right. It's 1 and 3, is that correct? 1 and 3. Okay, so we're going to have to use some logic in this one. We're going to get 3 minus 12, negative 9. So that's a bit curious. When we measure things, we usually don't have a negative measurement to it. Everything is usually in the positive round. Let's take a look at the other value it gives us. This would be 3, that should be an n there, 3 times 1 minus 5 times 3. Now we're going to get 3 minus 15, okay, which is going to give us negative 12. So while our area will be a positive value, what will it be? We give her 12 and 9, 18, 9, 10, 108. While it'll be positive 108, which makes sense, we have negative measurements for these. So that's very questionable. I would write something about that. Unlikely, correct, because negative side lengths. Negative side lengths. That's usually uncommon. You could say that you're doing like a measurement from on a Cartesian plane and they're to the left and downwards or something, but I think they said this was a parking lot. It doesn't really make sense to measure something in a negative. So this seems like unreasonable values for M and N. The other thing they told us was perimeter. Perimeter, M was 3 and N was 1. So they swapped them around but wanted to know perimeter. Okay, so do this one in a little different color. Perimeter, what would that equal if M is 3 and N is 1? Okay, I'll do a really rough sketch of the rectangle again, just so we have our values. 3m minus 5, and I think the other one was 3m minus 4n. 5n, 3m minus 4n. Okay. In this one, m is 3, so we'll do 3 times 3 minus 4 times 1. That gives us 9 minus 4, gives us 5 as a side length. And 3 times 3 minus 5 times 1 gives us minus 5, gives us 4 as a side length. So for perimeter, we're actually going to end up 5 plus 5 is 10, 4 and 4 is 8, 10 and 4 is 18. So the perimeter in this case is 18 units. This one makes sense. We could say those are reasonable values for what we're working with. But I would question the area one, that the M and N, because we usually don't make measurements in the negative range of anything. Okay, and there's our work in our question.